I'll go over application of solving a right triangle, section 2.5. Now here, when it comes to application problem, it will often talk about a bearing of an angle, let's say 120 degree. Now, when it comes to application problem, a bearing of an angle always without north and south written, just angle, or it may be sometimes a heading, 120. You always start from the directly north and you would turn clockwise 120 degrees. So that will be 90 and 30 degree more. And that's the bearing of 120 degree. From observer's point of view, object over here has a bearing of 120 degree. Now sometimes they will speak of a heading or bearing of south 60 degree east. In that case, you start from the south, directly south, and then you are tilting towards 60 degree east. So if a object has a bearing south 60 degree east, then object is here and observer is standing at here. And so that object has a bearing of south 60 degree east. Now, what is a bearing of north 35 degree west? Then you start north and you would tilt toward the west 35 degree. So an object is over here, an observer is looking at an object, and that object has, from this observer's point of view, has a bearing north 35 degree west. And so now if you know these are the bearing or headings in application problem, we can do the following examples. Now a boat is traveling on a course of a bearing of south 55 degree west. So boat leaves a port here, and then boat is not driving to going toward the south. It's south 55 degree west. So you would tilt toward south 55 degree west. So you will toward from the south, you will tilt, go toward to west 55 degree. So the boat is going this direction, leaving this port. And now it travels at 340 miles already. And the question says, how many miles directly south and how many miles directly west has the boat traveled? So we are talking about this distance, directly south distance and directly west distance. And so if I draw this one, you will see that right triangle right here. Then 340 miles is the length of hypotenuse, because it's an opposite of 90 degree. Then directly south distance that the boat traveled is an S, which is adjacent to the angle 55. So south distance, directly south distance over, south is acting as adjacent to the angle. Adjacent over hypotenuse, 340 miles, should be equal to cosine 55 degree. Cosine is adjacent to the angle over hypotenuse. Now, if you multiply 340 miles both sides, and then direct south distance will be 340 multiplied by cosine 55 degree measure. So 340. Oh, let me check whether its mode is in the degree mode. So it's radian mode. You must go down to set it to degree mode. Enter, second quit. 340 multiplied by cosine 55. And so that's the distance traveled south. So if I approximate this one to whole number, then 195 miles directly south distance the boat traveled. Now the west, direct west distance, which is opposite of the angle 50. So in that case, I would use a sine 55 degree. Sine 55 degree is the opposite side, which is direct west distance over the hypotenuse. So as before, west is I multiply 340 both sides, 340 multiplied by sine 55 degree. And now calculating 340 times sine 55. That's about rounded to whole number, 279 miles. So that's 279 miles. That is the first example, which asks you direct south distance and direct west distance the boat traveled. Now let's look at next example. Example 2, radar stations A and B runs on east-west line. So you would draw a line segment. The point A, radar station A, and then the other end of line segment B is radar station B. And now they are 3.7 kilometers apart. And station A detect the plane C, which has a bearing of 61 degree. Again, bearing start from the north and you turn clockwise 61 degree. 61 degree. So plane is observed here from station A. Now from the station B, the same plane has a different bearing because you're looking at from here. And the bearing of the same plane from station B is 331 degrees. So start from the north, bearing of 331, you go to clockwise, 180, 270, plus 61 degree more. And so this one is 331 degrees. So it's a 270 plus 61, which makes 371. So this angle measure right here will be 331, take away 270, which gives me same angle measure as this one. Since this angle equals 61, the same measure as a straight line right here, this angle measure should be equal to this angle measure, meaning these two sum should be 90 degrees, which makes it, since angle A and angle B sum is 90 degrees, angle C will be the right angle. And so this one is 61 and this one is 90 degree minus 61, so which is 29 degree, which possibly you don't need that. Now this distance between AB is 3.7 kilometer. The question says find the distance of AC, which I'm going to label as an X variable. Now X is the opposite of 61 degree and 3.7 is opposite of 90 degrees. So 3.7 is acting as hypotenuse. So sine 61 degree is opposite over hypotenuse. So X is equal to 3.7 times sine 61 degree. So going to calculator again, 3.7 times sine 61 degree. So the distance A is about 3.2 kilometer. So this is about 3.2 kilometers, and that's the distance AC. Now let's look at example 3. Now this one has a bearing from A to C. That means object C, it has a bearing of south 50 degree east from A. So I will draw A is here, and south A is here, and C has a bearing from A 52 degree east. Now the bearing of B from the same point A has a north 84 degree east, 84 degree east. And so there is B. And the bearing of C from B has a south west 38 degree. Now, you know, these two dotted lines are north-south lines, so that means they are parallel lines. So if I draw another vertical line at now this vertical line is parallel to the north-south line. So that means this angle measure and this angle measure alternate interior angle, which is 38 degree. Now since the red line and the dotted lines are parallel, 52 degree is equal to this alternating interior angle and that's 52 degree. So angle C is 38 degree plus 52 degree, which is some 90 degree, which makes C as a right triangle, right angle, 90 degree. Now this angle measure is a supplement of the sum of 84 and 52. So this angle A is 180 degree minus 84 and minus 52. And if you do the subtraction, it's 44 degree. So this is 44 degrees. So 84 plus 44 plus 52 should be 180 degree. So now angle A is 44 degree. Now it says a plane fly 250 miles per hour. It takes 2.4 hours to travel from A to B. So that means distance from A to B is the speed multiplied by time, which is 600 miles. And since it's a right triangle, 600 miles is hypotenuse, and angle 44 is given to you, and then say find the distance between A to C. So that's my x. So x is adjacent to 44. So cosine 44 degree is adjacent, which is x, AC over hypotenuse 600. So AC, x is equal to 600 times the cosine 44 degree. So if you multiply 600 times cosine 44, it is giving me 431.6 miles. 431.6 miles approximately.